Okay, so in this arhennius equation, general equation K equals A e raised to minus EA divided by RT, where EA is a frequency factor, and the most useful form of the arhennius equation, which is ln K2 divided by K1 equals EA divided by R, and for two temperatures, 1 over T1 minus 1 over T2. That means two temperature conditions are given and we need to find out the activation energy. So this is the most useful equation. Alright, so let's go for next example. Alright, in a series of experiments on the decomposition of dinitrogen pentoxide, rate constants were determined at two different temperatures. At 35 degrees Celsius, rate constant 1.4 times 10 raised to minus 4 per second, and at 45 degrees Celsius, rate constant is 5.0 times 10 raised to minus 4 second, and we need to find out activation energy, and we need to find out the value of rate constant at 55 degrees Celsius. So there is actually two sets of problems. First, we need to find out activation energy, and the second, we need to find out the rate constant. Alright, so let's start with first. We have given temperature T1, which is 35 degrees Celsius, and when you convert into Kelvin is 308 Kelvin. Temperature T2 is given 45 degrees Celsius, and when we convert into Kelvin, 318 Kelvin. K1 is given 1.4 times 10 raised to minus 4 per second. Okay, and K2 is given 5.0 times 10 raised to minus 4 per second. We are going to use this equation. ln K2 divided by K1 equals EA divided by R, 1 over T1 minus 1 over T2. Now when we plug this value in, so let's start with ln K2 value is given 5.0 times 10 raised to minus 4 per second, and K1 value is given 1.4 times 10 raised to minus 4 per second. EA, activation energy, we need to find. R value is, in this case, 8.315. Unit is joule, mole times Kelvin, and temperature 1 over 308 Kelvin minus 1 over 318 Kelvin. Alright. So we will solve left side and then we will rearrange the right side. So when we solve for left side, so let's start focusing on this one first. When we solve left side, you get 1.273 activation energy. We get 10K divided by 8.315. I'm not gonna write units. 318 Kelvin and 308 Kelvin. Okay, and then when we rearrange, we can separate for activation energy. I'm gonna go to next page, and EA, activation energy, 1.273, 8.315, 318 Kelvin, 308 Kelvin divided by 10 Kelvin. And when you calculate, you get activation energy is 1.0 times 10 raised to 5 joule per mole. That's the first one. Now when you solve for K, you plug those values in and you get K1 value and K2 value, which is here. Yes, K1 value is given, you need to find out K2 value. I'm going to give you the answer, but we'll work on that one also. K2 value, when you calculate, 1.7 times 10 raised to minus 3 per second. So that's two things. We can find activation energy and constant K2.